In this video, we're going to practice how to solve quadratics using the completing the square method. To start off, we're going to look at the do now, and we're just going to factor each of these trinomials completely. So since it's the trinomial method, we want to add to 16, but multiply to 64. So we know we start with our two parentheses. We would put x in both, and now the numbers that multiply to 64 and add up to 16 are positive 8s. In part B, same concept. We're going to set up our parentheses, only this time we have x minus 6 and x minus 6 as they multiply to a positive 36 while combining to get a negative 12. In the last part C, you could use the headphones method by just doing the 2 times 18 to get 36, but we can also try to do a GCF first, which does work in this case. We'll pull out a 2 to have x squared plus 6x plus 9, which we can factor further. Now we can trinomial again. This time we're going to have x plus 3, x plus 3. Now you might have noticed something special about all three of these questions to do now. Each of their factors were the same in both parentheses. That means I can rewrite this as x plus 8 squared, or x minus 6 squared, or finally x plus 3 squared. But notice part C would still have that with. You don't have to write these like this. This is just a way the regions could still show you the expression. But what you should know about A, B, and C is they're known as perfect square trinomials. What that means essentially is that the two factors were exactly the same. They're perfect squares of each other. We can use those to kind of help us with our completing the square method today. So in class, we talked about the quadratic formula to solve. Now we're going to focus on completing the square. We did this back in Algebra 1 and last year in geometry as well. So we have 6 steps written out for us. The first step that you should always check is that A, that leading coefficient of the quadratics, has to be equal to 1. If not, we want to divide out any terms to try to make sure we're equal to 1 in that A term. Otherwise, it's going to mess up our whole completing the square method. Then the following step is to move the constant term over. That's the C term. So anything without a variable attached should be sliding to the opposite side of the equal sign. We want to be able to make perfect square trinomials in the next step, like we just saw, like ones that we saw from the do now. So we're going to find a way to do that. To figure this out, we take half of the term, that's B, and then square it. Finally, when we have that trinomial, we're going to be able to factor, and we can follow through by solving. But one thing we definitely don't want to forget about is the plus or minus that we're going to bring to the table. Now, I know I've just told you a lot of steps, and you might not remember that. So let's actually attempt to do this first. What I should remember, though, is when do you have to use completing the square? When you're solving quadratics. Now, we are up to our third way to solve quadratics. We know we could potentially factor and solve. We can use the quadratic formula, or now we're going to be able to use completing the square method. If the Regents wants you to do a specific one, or if I want a specific one, I'm going to tell you which method to apply. If it just says to solve, then you have the right to choose any of those 3. But remember, quadratics are exponents with the highest degree of 2. So it can only be for quadratics, otherwise this will not work. But let's see how it works and see if we remember how to apply the quadratic formula, or the completing the square method. So the first thing, our first step was to move the constant over. That's the C term, the one without a variable attached. So I'm going to have x squared minus 12x some number equal to negative 23 plus some number. Now, you don't have to put this box. You could just leave yourself a space. But remember, my goal was to turn one side into a perfect square trinomial. So we're trying to complete what's missing from making this perfect square. The way we figure this out is taking the B term. So that's the term in the middle, that negative 12, and we're going to take half of it. So we're going to divide that by 2. When we do that, we end up with a negative 6. But we're trying to complete there. So what we still need to think about is squaring that number. So negative 6 squared is 36. I'm going to take that 36 and add it to both sides. Now you might notice from the do now, if we saw negative 12x, 36 definitely was that perfect square trinomial. Same thing. But now I can actually use this. I can factor. So just like we factored in the do now, we would have x minus 6 and x minus 6, which we also know can be rewritten as x minus 6 squared. And then on the side, we would just combine those like terms. We have negative 23 and 36, which combine to get a positive 13. Now, we could expand this and try to solve a different way, but we're doing the completing square method. So what we want to look at is to cancel out a square, we take the square root of one side. And whatever we do to one side, we do to the other. Now, one thing I want us to be careful about is that if you put a square root on one side on your own, it wasn't there in the original problem. Remember, there's two potential answers. Okay, we can either have a positive or negative in front. So that's what I meant in the directions of not forgetting the plus or minus. But when we apply that, the square and the square root cancel out. So we're left with x minus 6 on the left equal to a positive or negative radical 13. And there's only one step remaining to get x by itself. We're going to add the 6 to both sides. And we can only combine radicals if their radicals match, which this is not. So we're going to leave a 6 in front with a plus or minus square root of 13. Those are my two solutions for this quadratic equation here. We can't simplify that radical 13 at all, so we know we're done. Let's try that one more time together. So when I go to set up our next clean the square, remember our first step was to add the 16 to both sides. So we get x squared or x. I'm going to put some space in between. Like I like to put a square to remind myself to complete the square to fill it in. But it's going to be equal to 16 plus whatever you add to one side, we're going to add to the other. Now remember, we fill the square by taking that middle term, 4. We take the half of it, we divide it by 2, and we square it. So 4 divided by 2 is 2. When I square that, we will get 4. So it means I'm adding 4 to both sides of this equation. At this point, we can factor this. So the only thing that multiplies to 4 and adds to 4 is going to be x plus 2. Now we know we've done it correctly if we have the same factors. Remember, the whole point is to complete the square. We want to write the left side as a perfect square trinomial, so we can write it as a factor squared. On the right side, we're going to have 60 plus 4, which is 20. And then we take our square root of both sides. Not forgetting that we need a plus or minus here. So we need positive or minus square root of 20, because then everything else will come and drop out. We'll have x plus 2 equal to positive or negative square root of 20. And we will subtract 2 from both sides, so x equal to negative 2 plus or minus square root of 20. There's still one thing I have to be careful of, though. Over here, you may notice simplest radical form. The first one we did was in simplest radical form. This one, however, is not. We can break up that square root of 20. So we need the biggest perfect square that multiplies with some other number. It's going to break up to 4 and 5, which means I'm going to replace this with a 2 radical 5. So the radical 20 is being replaced with the 2 radical 5. And everything else can just come down with it. So we have x equals a negative 2 plus or minus 2 radical 5. Then I know that I'm in the simplest radical form, and I've combined everything that I could. Now, we saw an example similar to this in class with the quadratic formula. However, I want to be careful that I want a squared to only equal 1. So you may recall the way we handle this is by multiplying both sides by 4. So we have to make sure x squared, because now that 4 will cancel, so I'm left with x squared here. And whatever I do to one side, I do the other. Be careful that we would have to distribute the 4 to both. So I'm looking at 4x subtract 8. Now it's up to you if you want to move everything to one side first. But remember, the constant's going to get left alone anyway. So I might just rewrite this x squared minus 4x plus some number equal to negative 8. That way the constant is already on the right. And now we just have to fill in that completing the square. So we already dealt with 4 before, but this time it's a negative 4. When we divide it by 2, it would be negative 2. But when we square it, we will still end up with 4. So if you know your perfect square hand, you don't have to show the work that goes with it. If you feel better about the work, then but when I factor, I'm looking at x minus 2 instead of x plus 2 because the sign of that negative 2 in between changed. So we have x minus 2 equal to a negative 4. And we know to take the square root of both sides. And when you take the square root of both sides, we're looking at a positive, negative in front. So I'm going to drop that x minus 2 out of the radical now. Plus or minus the square root of negative 4. We know that can simplify. And we had this little hint that we were going to worry about simplest a plus b form. So I'm kind of feeling good because negative underneath the radical is going to be imaginary. So the square root of 4 is 2. And we'll pull out an I with it. That being said, the last thing to getting in simply plus bi form is to add the 2 on both sides. So I'm looking at 2 plus or minus 2i. Only thing left is question 4. Remember that rule we talked about in the very beginning. I can't complete the square when there's a number in front of x squared. So I've got to get rid of that. To get x squared by itself, I'm going to divide both sides by 2. So now I'm looking at x squared plus 6x plus some number equal to negative 8 plus some number. Notice the constant's already been moved for us, so we don't have to worry about that. Not just business as usual. So why don't you pause the video here and see if you're able to do the completing the square method without me. So pause it and then regroup when you're ready. To this point so far. So remember, I would have filled in my completing the square method to get 9 on both sides, which means it would have factored to x plus 3 squared equal to 1. And then when I take the square root of both sides, I have a plus or minus 1. Now I came back at this point because the square root of 1 is just 1. So we have plus or minus 1 on the right, x plus 3, but I wanted to make sure no one got too nervous. This does mean there's 2 possible solutions. One of them is that x plus 3 is equal to positive 1, and the other is x plus 3 equal to a negative 1. And you have written that over, and I could have moved the 3 first and had negative 3 plus or minus 1 and done the same thing. It's your call. But we're just going to solve here. So x is equal to negative 2, and x is equal to negative 4. So there are 2 solutions in here. There's no radicals left. That means that this could have been factored. But we could always use the completing the square to work, and we could have even done the quadratic if we wanted to. any of those three methods will work.